For our second example, you will need the STMEMS ISPU GitHub repository. I already cloned the repository in here, which contains two folders, tutorials and examples. In examples, you can find the same folder structure that you saw in the Xcube ISPU package. However, here you will find new and updated examples. For instance, the SDFT. So if we open it, we can see a README file that describes that the example implements a sliding discrete Fourier transform at 26 Hz. Then you have the usual output folder containing the pre-built files. But for this hands-on, I want to show you how to use the project folder in order to configure the example for your needs. So now we can go back to the Cube ID and import the STFT example. This time we will browse into the GitHub repository, into the STFT example and the Eclipse folder. So the example is important. Let's open the code. What I want to show you here is the parameter for the window length. So this is the length of the window over which the discrete Fourier transform is computed. As you can see, at the moment is configured to 26 sample, which means 1 second at 26 Hz. What we can do, for example, is to change the data rate to 12.5 Hz and then modify the window length. For example, let's configure it to 2 seconds. So for 12.5 Hz, this will correspond to 25 samples actually. Alright. So this is really all you need to modify, because then everything is applied automatically in the configuration during the initialization code. And then also automatically the MotionFT library is run to compute the magnitudes of the DFT. And then with a 4-cycle, the values are copied to the output registers of the ISPU. So then what you have to do is also go here. We have the configuration file. And if we open it, we can see that indeed both the accelerometer and ISPU are configured at 26 Hz. So we can modify this and set instead to 12.5 Hz, like so. Good. So with this, we can go back to the Cube IDE and build our example. Now, in order to visualize the results, we can use Uniqlo GUI. For this purpose, first of all, we need a JSON file describing the outputs. So let's copy the one from the example into our build folder here. And let's rename it as ISPU.json. Okay. Then if we open it, what we have to modify is the size here of the array of the DFT magnitudes. So if we go back to the Cube IDE, we can see how this length is computed. It's computed by dividing the window length by 2, rounding down and adding 1. So in our case it will be 25 divided by 2, which is 12.5, rounded down to 12 plus 1, 13. So we change this from 14 to 13. So the next step is to flash the Nucleo board with the appropriate firmware. To do so, let's go back to the Xcube ISPU package. Into projects, let's select our Nucleo board and then the expansion board that we are using and our sensor. And then in the binary folder, we have the pre-built binary of the firmware, which you can flash just by copying it to the Nucleo board. Okay, now that it's flashed, we can open Uniqlo, which will automatically connect to the board. We can press start and then go into ISPU here. Then browse for our UCF file. So let's find the STFT example. Let's go into our build folder to load the UCF. Okay, so you can see that here is computing the magnitudes at the various frequencies. And right now the values are all close to 0 because the device is stationary. But if I start shaking it, we should see some frequency components appearing. Okay, so this is just, let's say, a visualization for the results, but the STFT algorithm is a starting point. So in a real application, what you will do is run the STFT according to your needs, and then here, instead of copying the results into the output registers, you will be able to use the output of the library as an input for further processing and for your vibration monitoring algorithms.